Section 1 dealt with solving systems of equations using graphs and tables. Section 2 moves away from that and gets into algebra. Solving systems algebraically is definitely way more powerful than using tables or graphs could ever be, because your graphs are always going to be slightly inaccurate. Hopefully not that inaccurate, but inaccurate enough to where you're not going to get exact answers if you're not dealing with just integer values. So in this section, we're learning how to solve systems algebraically. There's two ways to do it: substitution and elimination. You learn both of those in Algebra 1. So we're going to review them in this section. First of all, your vocab. Equivalent system is just any system of equations that I give you, and then you do something to it, like solve for a variable or perform some sort of property of equality to both sides of one of the equations. If you do something to a system, anything, then you have rewritten a new system of equations that is equivalent to the first one, and that is what an equivalent system is. So to use substitution or elimination methods, typically you're going to have to rewrite or multiply or divide or something, which means you're going to have to write an equivalent system. Also keep in mind that if we were graphing a system of equations, doesn't matter if they're linear or not, the solution to the system is where the two graphs cross. So right there would be the solution to my system, okay? Because the ordered pairs that make this equation true are all on this line. The ordered pairs that make this equation true are all on this line. The only ordered pair that makes both equations true, meaning the entire system true at once, is that ordered pair right there, the place where the two graphs cross, or places where the two graphs cross. So keep that in mind. I actually repeat that right here. Solving a system using substitution is the first thing we're going to do. Now, this little blurb right here, since the solution of a system of equations is where the two graphs cross, at the intersection we know, because those two graphs are crossing, that the x-coordinates of the two equations are equal, as well as the y-coordinates. They're sharing that ordered pair, which means when they cross, the x in one equation is the same as the x in the other equation. The y in one equation is the same as the y in the other equation. And that is the only reason why we can use substitution. Like if I substitute out 4/4 for $1, I still have $1. To solve using substitution, your 4 steps right here. Again, it's just a review of Algebra 1. Solve an equation for a variable. Doesn't matter which equation, doesn't matter which variable. Then substitute what you get from step 1 into the other equation, and this is very important right here, the other equation for that variable that you solve for, and use parentheses. Once you do that, you'll have a new equation. It'll be complicated looking, but it is a new equation with only one variable in it. So step 3, solve the new equation for that remaining variable. You'll get like x equals something or y equals something. Back substitute into an original equation to obtain the value of the first variable. You need to go back to an original equation because if you made a math mistake somewhere along the way when you solved the first equation for a variable, you may not catch that mistake, and then it will lead you to thinking that you have the right answer. So the first example we have here to solve using substitution, we have a system of equations. Both are written in standard form, which is not good when we're trying to use substitution. So we want to pick a variable to solve for. It can be either variable in either equation. Which one do you want to pick? Y in the bottom one is the best option. Why? Yeah, it's already just one y. You're not going to have to divide and make fractions. So off to the side or something, make a note to yourself. Look for the variable that's going to be easiest to solve for. In this case, the y is definitely easiest. So let me get rid of that circle. And now I'm going to solve that bottom equation for y. When I do, all I have to do is subtract 2x from both sides. So that gives me y equals negative 2x plus 10. Or you could write 10 minus 2x. Doesn't really matter. Doesn't have to be in slope-intercept form. Once I've done that, now I know exactly what y has to be when we have our intersecting lines. It has to be negative 2x plus 10. So that means that I can take what y is, the negative 2x plus 10, and substitute it into the other equation right there. That is the value of y. So I take that and plug it in. And now I'll rewrite the first equation using my substitution. So I just start writing that first equation over again. 3x plus 4. And now I'm substituting in that equation that I have. So parentheses, y is negative 2x plus 10. Finish off the equation, equals 12. So now we have this complicated looking equation here, but there's only one variable in it, which means we can now solve for x. So I'll take out this distributive property situation here, 3x. I have 4 times negative 2x, which is negative 8x. And then 4 times 10, which is positive 40, equals 12. After we distribute, we have to combine like terms. I have a 3x and a negative 8x, which gives me what? Negative 5x. Then I have the plus 40 equals 12. Now what? Okay, subtract 40 from both sides, and we get negative 5x equals negative 28. Now what? Divide both sides by negative 5. And I get x equals, that's a negative 28 divided by a negative 5, which is positive. 28 fifths does not reduce, so positive 28 fifths is my answer. And I don't need to circle that one, but I did just so that we can see it. So now I need to take that 28 fifths and back substitute to obtain the value of the other variable. Okay, so I take this 28 fifths and I plug it back into one of my two original equations and solve for y. Which one do you want to use? 2x. The 2x one? Okay, fine. So we have 2 parentheses 28 fifths plus y equals 10. So I can distribute that and I get 56 fifths plus y equals 10. And then I can subtract 56 fifths from both sides. When I do that, I'm left with y equals, what's 10 minus 56 fifths? Well, 10 would be 50 fifths, so 50 fifths minus 56 fifths gives me negative 6 fifths. Now I know what my x value has to be and what my y value has to be. So now I'm going to write my answer just like we did in the last section as an ordered pair, x comma y. So 28 fifths, comma, negative 6 fifths. Then what should we do? Yeah, check your work. Okay, first one on the left. What should we do? Solve for the top x, because that top x is already by itself. So I'm going to draw an arrow over and write what? X equals negative 3y plus 5, okay. By the way, we now have an equivalent system of this equation and this equation. That's an equivalent system. So now what? Okay, so I'm going to substitute that in for x. What would I write? Okay. Make sure you do substitute into the other equation. If you don't, you're going to wind up with something weird like 0 equals 0 in the end, and that's usually the clue that you did something really wrong. Now what? Okay, so we get 6y minus 10 minus 4y. Okay, now what? So we get, yeah? Why is it a negative 5? We're rewriting this equation, substituting this in right here, or that right there. We finish off the equation with that negative 5. So now what? Okay, add 10 to both sides, and now I have 2y equals 5, so y equals 5 halves. Now what? Okay. X plus 3. Yep. Okay, and then we solve that. So we have x equals 15 halves. Sorry, x plus 15 halves equals 5. Where would the negative 3 have come from? We go back to an original equation. Go back to an original equation. Go back to the original. Get in that habit, because if you made a math mistake solving for x, which I know we didn't here, then you'll have carried that mistake all the way through and you won't catch it. So we subtract 15 halves from both sides, and x equals, this 5 turns into 10 halves. So 10 halves minus 15 halves gives me negative 5 halves. So my answer then is the ordered pair negative 5 halves, comma, positive 5 halves. And then you'd want to check that. Go ahead and do the last one on your own. Which variable do you want to solve for? Which one's the easiest one? Second equation, which variable? It doesn't matter. Just pick it and go with it. So how many of you picked x to solve for? How many of you picked y to solve for? It's like 50-50, okay? I'm just going to pick x. So I'm going to subtract y from both sides, and I get x equals 3 minus y. Or negative y plus 3. It doesn't matter if you write it in slope-intercept form or not on these. So now I take what x is and I substitute it in right here. This is going there. So I write 5 parentheses. X is 3 minus 3y equals negative 1. Then we distribute 15 minus 5y minus 3y equals negative 1. After we distribute, we always combine like terms. So these combine to give me negative 8. 15 minus 8y equals negative 1. I subtract 15 from both sides, and now I have negative 8y equals negative 16. Divide both sides by negative 8, and I get y equals positive 2. Go back up to an original problem. I'll use the bottom equation because that seems pretty easy. X plus 2 equals 3. Subtract 2 from both sides, x equals 1. So my answer then is 1, 2, and you do need to give me an ordered pair as an answer, otherwise it will be wrong. Put a box around it so that I know that that's what you intend your answer to be, and then check your work. This is the correct answer though, and don't ever say that I don't give you the easy problems to try on your own, because this was definitely the easiest one of all. So the other method we're learning in this section is solving using elimination. Most people prefer elimination over substitution, but sometimes you can't get around substitution. So the elimination method just involves writing equivalent systems using the properties of equality so that you wind up with opposite terms. Once that happens, then you can add the two equations together, and one of the variables will eliminate. So to do that, you want to choose a variable to eliminate. It makes no difference which one you pick. Usually you're going to want to pick the one that makes the most sense, so the easiest one to get rid of. But you can pick either, it doesn't matter. Create opposites between the equations by multiplying one or both equations by a constant. A constant is just a number that you're multiplying in. If you have a number that you're multiplying in, then that is called a scalar. Then, once you have those opposites, then you can add the two equations, which will eliminate one of the variables, the one that you picked to eliminate. Once you've done that, solve the new equation for the remaining variable. Again, you get like x equals something or y equals something. And then once you have that, back substitute like we did before into the original equation to find the value of the eliminated variable. And it does need to be into an original equation. You do not want to use any equation that you made after the problem started. So, start off basic. Solve the system using elimination. Take a look at the two equations. Look at each variable and ask yourself, do I have opposites here? By opposites, I mean the same number, just different signs. So if I look at x, I have positive 4x, negative 4x. If I add those together right now, do I get 0? Yeah, I do. I have positive 2y, positive 3y. If I add those together right now, do I get 0? No, I don't. So, the right move here would be to just add the two equations together because we already have opposites right here. Choose a variable to eliminate. I choose x. Create opposites. They're already there. So, add the equations. 4x plus negative 4x is 0. It's gone. And then 2y plus 3y is 5y. Equals 9 plus 16 is 25. The x variable has been eliminated. Now solve the new equation for the remaining variable. So we're going to solve for y, divide both sides by 5, and I get y equals 5. Now we know what y is, so now we're going to, step 5, back substitute into an original equation to find the other variable. Which equation do you want to use? The top one, because we're dealing with positive numbers, that's fine. So all right, 4x plus 2 times what y is, which is 5, equals 9. So 4x plus 10 equals 9. Subtract 10 from both sides. 4x equals negative 1. Divide both sides by 4, and you get x equals negative 1/4. I guess I didn't need to circle that, because my actual answer needs to be an ordered pair. Negative 1/4, comma, 5. That's my answer. And then we need to check that. Take the negative 1/4, plug it in for x. Take the 5, plug it in for y. It's very easy to do. Negative 1/4 times 4 is negative 1. This becomes 10. Negative 1 plus 10 is 9. Negative 1/4 times negative 4 is positive 1. 3 times 5 is 15. 1 plus 15 is 16. So this is the correct answer. That's how you solve using elimination, and as you can see, it's a lot less work some of the time. So that's why people typically choose elimination over substitution. So take a look at the next one. Follow the steps. Look at your two variables. If I add right now, does one of them disappear? Yeah, which one? The y term disappears. So I'm ready to add right now. What do I get? 3x equals 12. Then we divide both sides by 3 and we get x equals 4. Now what? Substitute it into one of the two equations. I'm going to pick the bottom one. So I have 5 parentheses 4 minus 8y equals 20. That makes 20. What? Minus 8y equals 20. So then I subtract 20 from both sides, and I get negative 8y equals 0. Now what? Divide by negative 8 and we get y equals 0. Don't freak out just because you see a 0. 0 is a number. So then my answer becomes 4, comma 0. Substitute, we get negative 8 plus 0 equals negative 8. That's true. We get 20 minus 0 equals 20. Also true. So this is the correct answer. Very easy to check, so do it. Go ahead and do the third one. Are we ready to add right now? Okay, so we do. And we get 6x equals 60, so then x equals 10. Now substitute. I'll pick the top one for fun. 2 times 10 minus 3y equals 14. So that's 20 minus 3y equals 14. Subtract 20 from both sides, negative 3y equals negative 6. Divide both sides by negative 3 and you get y equals positive 2. So then the answer is 10, comma 2. And then check. So obviously those three examples we just did using elimination were very easy. They were ready to solve without having to do any sort of manipulating. That's not how most of these problems are going to go. So you need to learn how to manipulate these so that you get opposites so that you can add and have something disappear. And that's what's going on here. When opposites are not present, you must write an equivalent system using the properties of equality. So go back and look at the variables and decide which one's going to be the easiest one to eliminate. For my system here, I have 2x, 3x. I can't add right now and have them eliminate. I have 7y, 5y. Again, I can't add and have them eliminate. You only add when you can eliminate a variable. So we need to do stuff to both of these equations, maybe one, but definitely both in this case, to make a new system of equations so that we come up with opposites. All right? So just pick a variable. Do you want to get rid of x or do you want to get rid of y? Either one, doesn't matter. For me in this case, because I'm dealing with 2 and 3 and I'm looking for the least common multiple of 2 and 3, I know that's 6. For these two, I'm looking at the least common multiple of these two, and that's 35. I'm going to be working with larger numbers if I try to eliminate y. So I'm going to try to eliminate x. Okay? Now my goal is to make these two numbers right here the same with opposite signs. So I need to multiply the entire top equation by something to give me that 6 sitting right here. What number does it have to be? 3. Now I need to multiply the bottom equation times something as well to get that 3x to turn into a negative 6. So multiply by negative 2. Now remember that is the entire equation that you're multiplying by. So this is how you do it. Draw a little arrow over. This represents that you're rewriting your system as a brand new system of equations, but it is an equivalent system. So now distribute the 3. We get 6x plus 21y equals 12. Now distribute the negative 2 for the bottom equation, and you get negative 6x minus 10y equals positive 10. Again, make sure you distribute that number to everything. That is where most people make their biggest mistakes. Now do we have opposites in x? Yes, so now we're ready to add. When we do, the x's disappear. I have 21y minus 10y, which gives me 11y equals 12 plus 10, which is 22. And now we can divide both sides by 11, and we get y equals 2. So a little bit of extra work there, but elimination is definitely still better than substitution. Now that we have y equals 2, we have to go back to an original equation. Just pick one of the original ones. I like the top one in this case. So I'm going to write 2x plus 7 parentheses 2 equals 4, and then just solve for x. 2x plus 14 equals 4. Subtract 14 from both sides. 2x equals negative 10. Divide both sides by 2, and x equals negative 5. So then my answer is the ordered pair negative 5, comma, positive 2.